example for factorizing over the complex field. For this example, we will be using a sort of substitution method, and this form is called the hidden form. So, example is going to be z to the fourth plus 4z squared minus 5 equals 0. So we call it the hidden form because it's sort of hidden that we can factorize this easier than it appears. So we're just going to make up a variable, w equals z squared. And that's easy because we see z squared there and z squared squared, in a sense, there. And by that I mean we can take w squared, because that's technically z squared squared, and substitute it. So plus 4, and this substitutes directly because z squared is equal to w right there as we define. Minus 5 equals 0. So all we've done is substituted w for the z squareds. Okay, now this is much easier to factor. So all we do is take w, and we have a plus 5 w minus 1 equals 0. Yep. Okay, so now that it's factored, we can resubstitute our z squareds. By that I mean we can take z squared back, plus 5, z squared now, minus 1 equals 0. And we can break these apart into their own things now, and set them equal to 0. Squared plus 5 equals 0. Subtract 5 from both sides. Take the square root of both sides. We get z equals... Now we're going to pull out the negative by taking out an I. So I square root of 5. And this is going to be plus or minus because of your square root. Now we're going to do the same thing for our other term. Z squared minus 1 equals 0. Z squared, we're going to add 1 to both sides. We get z squared equals 1. And we're going to take the square root of both sides, just like the other term. And that's going to be z, obviously. And we take the square root of 1. That's pretty easy. And we get z equals plus or minus 1 because we have to account for both square roots. Now we have 4 solutions, so we can write this as z plus I square root of 5 times z minus I square root of 5. Notice these are conjugates. And our other two factors, z plus 1 and z minus 1. And this all equals 0. So that is how you factor that example over the complex plane. Complex number field, sorry.